All right, this video is going to talk about how to solve absolute value inequalities. Absolute value inequalities. Again, this follows some videos on absolute value equations. So if you're unfamiliar with the method of solving absolute value equations, you might want to watch those videos first. Absolute value inequalities, though, there's really kind of two types. Remember that the absolute value talks about the distance from zero. So if we have an absolute value that's less than or also less than or equal to, but again, the key being less than a given number, what we're saying is the distance from zero is going to be less than that amount. So much like we talk about when we're solving absolute value equations, basically from our center, we can go out a certain number of units either direction, right? In either direction from that center. And again, you're going to have sort of two values going on there, one value to the positive side, one value to the negative. But now that distance could also be less than c units. So we out less than that amount. I'm okay with being closer to the center. So notice we connect the dots. Now, previously when we talked about compound inequalities, you may have noticed that, again, we talked about those as ands. You're basically greater than one number and less than another number. We're in between, if we call it that, in between those two numbers. If the absolute value is greater than or equal to, well, then we're going to go out that certain amount to those two given values, or we can go greater than that. So we could be possibly more than, right? Possibly more than that. Which basically just means, again, we're going to be on one line or the other line, right? One line or the other line. Let's go ahead and look at a couple of examples and see where that comes into play. That decision between and or is actually one you can make fairly early. So number one, we want to isolate the absolute value. Now you'll notice with this inequality that we have that absolute value isolated already. So we are ready to make our decision. Are we going to talk about and or? And we need to make that choice right when we decide to split this inequality up. So we're going to split into two parts. We're going to say that 11 minus 2x, right, could be greater than or equal to, just like it's written up top, 13. Because again, if the left side is positive, that absolute value wouldn't have done anything anyways. Or the negative of 11 minus 2x could have been greater than or equal to 13. Right? And it's very important that we put that negative on the left side over here. Again, the absolute value could have been positive or negative, but if it were a negative 13, then this extra negative would have put us right back to 13 again. Okay? Now, we need to make our decision for what goes in between, right? In between these two values. If our absolute value was greater than, right? And some teachers might even say greater than, we know that it's going to be an or. So right away, in between our two inequalities, we're going to write or. Then all we have to do is continue to solve. So on the left side, I'm going to subtract 11 from both sides, giving us a 2. And I'm going to divide by negative 2, telling me that x, now I divided by a negative, so that's going to be less than or equal to, right? I got to flip that sign, negative 1. Or, right, just carrying down our thought from earlier, I could divide this side by negative 1 on this inequality, giving me 11 minus 2x. Again, I divided by negative 1, so I'm going to flip the sign at least once here. Then I'm going to subtract that 11. So negative 2x is still less than or equal to negative 24. And now I'm going to divide by negative 2 again. So divide by negative 2. X will be greater than or equal to 12. And those will be, right, our statements. And remember, our expectation when we think about graphing this is that negative 1 and 12, x was less than or equal to negative 1, so solid dot going to the left, less than, or x could have been greater than or equal to positive 12 over here at the right. And that comes out to a very expectation, kind of a normal looking or graph, right? I could be greater than 12 or separate line, right? Less than 1, less than negative 1, that is. Let's go ahead and take a look at another example. So notice we have a lot going on in this one. So first things first, let's get our absolute value isolated. We're going to subtract this 15. So negative 2 times the absolute value of 1/4 x plus 10 is still less than negative 26, or make that 36, sorry. Then I'm going to divide away that negative 2 in the front, right? By dividing that whole quantity, all I'm doing is canceling that negative 2. So this becomes the absolute value of 1/4 x plus 10. And now I divided by a negative, so I'm going to flip that sign to become greater than 18. Now we're going to go ahead and split. I've got 1/4 of x plus 10 could be greater than 18. And because the absolute value is greater than, right, is greater than, well, again, greater, I'm going to go ahead and say or for this inequality right here. Again, if that would have been less than, then I would have said and. But again, we're going to say or. And again, negative, because I want to do the negative value of my statement, is still greater than 18. I'm going to divide away that negative right away, just telling me that, again, I'm going to flip that to being less than negative 18. That way in both equations, or both inequalities, I can now subtract 10. So this becomes 8, or 1/4 x, again, minus 10, so it disappears, becomes negative 28. And then finally, to get rid of that 1/4, we just want to multiply by 4, right? Times 4. So I'm going to do that in all parts here, times 4. And we get that x could be greater than 32, or x could be less than, and now this is going to be a negative. 20 times 4 is 80, and 8 times 4 is 32, so a negative 112. Again, because that's an OR graph, I fully expect that negative 112 and 32. I kind of expect no equal signs, so open circles. But again, with an open circle, I expect this one to go to the right, which makes sense. X was greater than 32. And again, going left, x is less than negative 112. Now, I hope that helps you solve in those equations. One place that we can actually see this come into play and actually have it be useful is in what's called an absolute deviation inequality, or what's sometimes called a tolerance equation. One way we can use this in word problems is to say things like this. In bowling, a bowling pin has a legal weight. If it's too light, they'll fly around, and if it's too heavy, they'll never get knocked over. So there's a legal weight so that everybody's bowling with essentially the same bowling pins, right? The same general weight of a bowling pin. Those pins need to be between 50 and 58 ounces. So if we had to think about the perfect weight of a bowling pin, well, I would take the average of those two, right? Cut them in half and figure out that a perfect bowling pin should be about 54 ounces. But if we're willing to be a little heavy or a little bit light, right? Nothing in the real world's perfect. We're willing to sort of give and take about 4 ounces. So if we were looking for a way to write down what's a way to find the acceptable weight of a bowling pin, we could say that x minus 54 minus the ideal weight, well, x being the actual weight, well, the difference between those two weights just can't be more than, right? It needs to be less than or equal to 4 ounces. So that's a great way to write that. And the reason that we need the absolute value is, what if we said, well, the bowling pin is 52 ounces. Let's just make one up, right? Let's say it was 52. Well, 52 minus 54 would come out to a negative 2. But the absolute value of that's positive 2, right? The actual distance between those is positive 2. And therefore, it's a good bowling pin, right? 2 is less than or equal to 4. So that would work out very well. Okay? Feel free to try a bunch of other possibilities if you want to, by plugging those in and seeing some good ones and some bad ones, right? Because we want to be able to say, well, hey, if I plug in something like 48, right? Well, 48 minus 54 is negative 6, which is less than 4, but the absolute value of that is not, right? Absolute value of negative 6 would have been greater than 4. So 48 is too light, right? It's outside the good range. Now, one last question we can consider. How would you rewrite that to say what bowling pins aren't accepted? Well, it's actually not that different. The weight of a bowling pin minus the perfect weight. Again, we still are only willing to give and take 4 ounces. But now if we're saying instead of the and, right, instead of the in between, right, what are the good bowling pins? We just want to say, what are the bad bowling pins, right? What are the ones that are too heavy or too light? Well, very simply, let's just change this to an or inequality. If the absolute value is greater than 4, if it's more than 4 ounces outside of 54, right, too heavy or too light, then it's a bad bowling pin. Just that simple. If you have any questions about absolute deviations and setting them up, right, you're aiming for the ideal. And again, you're either less than or greater than, depending on do you want to keep what's inside or get rid of what's outside. But again, greater than or less than the absolute deviation. Make sure you talk to your teacher. Also, if you have any questions about actually solving inequalities, talk to your teacher as well. Otherwise, have a great day.